Most users sit down with a chatbot and expect it to remember what they said 2 minutes ago, but large language models do not work that way. Out of the box, they are stateless APIs. They process every single request in total isolation. If you wire a user interface directly to a model and ask a follow-up question, the system fails. The model has no internal memory of previous requests or users. As soon as it returns an answer, it wipes the slate clean. The engineering challenge is building an illusion of continuous memory without forcing the frontend to handle the heavy processing of storing and compiling data. To solve this, we place a centralized middle layer between the user and the AI, in this case, a FastAPI Backend. This backend assumes the heavy lifting. It coordinates active session logic, writes to the database, and securely handles the calls to the external AI API. The backend, not the language model, is the actual brain orchestrating the logic of the conversation. The request lifecycle begins the moment a user's device establishes a connection to the FastAPI server. The server's first logical step is to inspect the incoming payload and look for an existing session ID. If the user is starting fresh, the backend generates a unique alphanumeric session ID on the spot. That token acts as a digital anchor. The backend links it to a specific table in the database to organize the upcoming exchange. Grouping messages by session is much cleaner than dumping every interaction a user has ever had into a single, unmanageable continuous thread. Because the backend compartmentalizes the data, users can open the interface later and select specific, discrete past conversations to pick up right where they left off. Session IDs provide the structural metadata required to make a sprawling chat history organized and easily addressable. To actually store that history, this architecture uses Snowflake as the designated database repository. The system must save a permanent record of every single prompt the user sends and every reply the assistant generates. But wiring the main HTTP web endpoints directly to the database introduces an architectural risk. It mixes web traffic logic with data storage logic, creating brittle code that is difficult to maintain. To separate these tasks, the system utilizes a data access object, or DAO, pattern. This diagram shows how the FastAPI server splits its responsibilities. The top layer contains the route handlers. Their exclusive job is to manage incoming web traffic and parse the HTTP requests. When data needs to be saved or retrieved, the route handler passes it down to the DAO layer. The DAO handles the secure connection out to Snowflake and executes the SQL commands. Isolating data access from API handling keeps the codebase modular. The DAO pattern ensures the backend is highly testable, organized, and totally insulated if the engineering team decides to migrate to a different database in the future. With the persistence layer established, we can track a specific user message payload hitting the main chat endpoint. The backend can optionally intercept this raw message here, cleaning or formatting the text before deep processing begins. Next, the endpoint reads the session ID and tasks the DAO with retrieving the user's previous chat history from Snowflake. The backend then stacks those historical logs together with the brand new user input. This assembled context block is what finally gets transmitted out across the network to the external language model. Packaging the context here removes the burden from the front-end client. The user's device does not need to juggle megabytes of chat history because the server handles it all securely. The external AI model processes that massive context block, generates a response, and fires the new text back to the server. Back-end context assembly is the hidden mechanical reality behind the seamless illusion of conversational memory. On the entire system architecture map, the back-end executes a dual routing maneuver upon receiving the generated response. It sends the text upward to the front-end UI. Simultaneously, the user's prompt and AI's response pass through the DAO, locking into the Snowflake database. This final write operation ensures the chat history is perfectly updated for the very next time the user asks a question. In the span of a single request lifecycle, the backend verifies identity, retrieves records, concatenates text, queries external APIs, and commits new data. The application relies completely on this centralized orchestration to function intelligently and consistently. Without this specific architecture, the product degrades into a basic interface attached to an amnesiac model. The system's data flow is now fully operational, but right now, the data moving through these pipes remains completely unprotected. True enterprise AI requires mastering the data flow and implementing the rigorous security parameters needed to protect it.